this MATLAB video tutorial. If you've never used MATLAB before, this demonstration will get you started and show you where to go to next to learn more. The MATLAB language lets you construct commands to create and process variables. You can create variables by entering them in the command window here. For example, a equals 1, b equals 2, c equals a plus b, or d equals cosine of a. MATLAB is an array-based language where variables can be vectors, matrices, or n-dimensional arrays. You use square brackets to construct arrays. To create a row vector, you can type t equals 1, 2, 3, 4, 5. You can use the colon operator to simplify the creation of equally spaced arrays. T equals 1 to 5. You can recall previously entered commands by either dragging them from the command history here, or by pressing the up arrow key. You can then edit them. T goes from 0 in steps of 0.01 to 1. Adding a semicolon avoids command output being echoed to the command window. To find out what variables you've created so far, type whos, or view a list in the workspace browser here. To see the value of a variable, just type its name, such as b. You carry out operations on vectors just like simple scalars. For example, y equals sine of 2 times pi times t. This makes use of the constant pi predefined in MATLAB. You can plot y against t with the plot command. In MATLAB, variables can be complex, with I used to denote the imaginary part, such as x equals 3 plus 4i. You enter matrices using the semicolon in the following way. A equals 1, 2, 3, 4, 5, 6, 7, 8, 10. Or you can use functions. You can browse a list of available functions in MATLAB by clicking this icon, and browsing available functions by category. Or by searching using keywords. Here we'll generate a matrix of random data. Double-clicking enters the function name. Pausing after typing a parentheses shows a list of possible arguments. Here we'll specify 5 rows and 5 columns. You can access help on all of MATLAB by clicking the question mark here, and either browsing for information or searching. You can access demonstrations and getting started documentation from this message bar here. You can find the size of a matrix by using the size command, which is also shown in the workspace browser here. You can perform matrix operations such as B equals A transpose, or C equals A times B, which performs matrix multiplication, or C equals A dot times B, which performs element-wise multiplication, where the corresponding elements of each matrix are multiplied. You can calculate the inverse of A and multiply by A to confirm you get the identity matrix. You can select elements or sections of an array by indexing. For the variable A, here is the value at row 2, column 3. Or for the variable data, here is the section, rows 1 to 3, columns 2 to the end. You can set values in this way too. For example, with data, you could set rows 1 to 2 and all the columns to 0. The colon operator used on its own in indexing specifies all elements, in this case, all columns. Note that array indices in MATLAB start at 1. And you can plot matrices as well if you wanted to display the matrix W generated by multiplying the transpose of the sine wave vector y with itself, you could type surf of w, which creates a surface plot. That concludes the demonstration. You can try some of these examples in MATLAB now, or watch one of the other videos. This video tutorial will show you how to create and run a MATLAB program. The command window is designed to execute individual commands one at a time. You can automate the execution of many commands or build a complex application by writing a MATLAB program. This is a collection of MATLAB commands and functions, also known as statements, stored on disk as a text file of type .m. You can create a new MATLAB program by clicking here, which opens the MATLAB editor. You can also create a MATLAB program from entries in the command history here. We will select these commands, then right-click to choose Create Script. This brings up the MATLAB editor again, which we will dock into the desktop for easier viewing. You save the file by clicking here and specifying a file name such as simple. This creates a file on disk, which you can see here. You can run this type of MATLAB program known as a script by just clicking the Run button. You see all the commands ran. You can also run the program by right-clicking the file itself and choosing Run File. You can make changes just like using any text editor. We will change 10 to 1000. You can type a script's name in the command window to run it. To call a program by typing its name, the file has to be located either in the current folder or on the MATLAB search path. The current folder is an important reference point for MATLAB file operations and is displayed here and in the current folder browser. The current folder browser displays the contents of the current folder and lets you change it by navigating the file system. You can open MATLAB files by double-clicking them here or using the Edit command. The MATLAB search path is a list of directories similar to a computer's system path. You add directories to the path by selecting Set Path from the File menu. You expand your MATLAB program by adding more commands and language constructs, such as we'll make x a column vector using the transpose operator and parentheses. Add a comment with the % symbol. Add a for loop statement for k equals 1 to 5, which repeats the next set of commands 5 times. We will multiply log of x by k and assign the result to each column of y. And add the end statement required for the for loop. There are a number of tools in the editor to help you write and format your code, such as Smart Indent, accessible from the right-click menu. Let's save the code, clear the workspace to remove the previous values of x and y, and run. Now when y is plotted, there are 5 lines, one for each of the columns in y. We can confirm that y is a 1000 by 5 matrix by looking in the workspace browser. As well as MATLAB script files like this, you can also create MATLAB function files. MATLAB function files start with the function keyword, have a function name that should match the file name on disk. You can specify optional input parameters. Here we will pass in the value for the for loop count and update the for loop. You can also optionally specify one or more output arguments. We'll save it, clear our workspace, then call our function, assigning the result to a variable g, and specify an input argument of 10. Here we see there are 10 lines on the plot, and g is the only variable returned to the MATLAB-based workspace. You can call a MATLAB function or script from another function or script, allowing you to create a large multi-file application. You can browse examples of other MATLAB scripts by looking at the demo section of the MATLAB help. Click here to view the code in the editor, and double-click the title bar of a window to maximize it. That concludes the demonstration. You can try some of these features now in MATLAB or watch one of the other videos.